Right now, as you listen to this, something unprecedented is unfolding in our solar system. The month of September 2025, a time that was supposed to pass with routine astronomical calm, suddenly became the stage for a drama that left scientists scrambling and the public looking skyward in wonder. For centuries, we've imagined the heavens as orderly, governed by patterns and cycles we could trust. But in these crisp autumn nights, the sky itself seemed restless, as if some deeper force had stirred its contents into motion. Ever since the discovery of 3I Atlas back in July, astronomers had sensed something unusual. At first, it was just a faint smudge of light, no different from countless other dots catalogued by survey telescopes every week. But the object carried a strangeness, its path, its chemistry, its very presence in our skies. And then came the disturbances, the sudden clustering of asteroids and comets moving through near-Earth space. Normally, the slow ballet of celestial traffic is predictable, each asteroid passing like a scheduled train, each comet keeping its well-mapped rhythm. But in September, the choreography broke. Clusters of asteroids arrived not singly but in waves. A comet brightened unexpectedly, unfurling its tail like a cosmic banner. And behind it all, in the shadows of these reports, lurked an interstellar visitor, the third ever confirmed, something ancient, foreign, and almost alien to our solar system. The effect was unsettling. It wasn't simply the number of objects, it was their timing. One after another, like actors entering stage right, each body seemed to arrive on cue, as if rehearsed. The press dubbed it a celestial parade. But among astronomers, the mood was far more complex. Was this just coincidence? The universe reminding us of its chaotic abundance? Or was there a hidden pattern, a gravitational confluence, a deeper mystery unfolding in real time above our heads? The strangeness was magnified by the way these events collided with public imagination. Humanity has always looked to the sky with a mixture of awe and dread. Ancient civilizations saw comets as omens, harbingers of kings' deaths or the fall of empires. The Romans whispered of disaster when fiery stars appeared. Chinese court astronomers kept meticulous comet records, knowing that a misplaced prediction could cost them their lives. Even in our modern age of supercomputers and planetary defense programs, that unease lingers. When 7 comets suddenly cluster together, when asteroids sweep past in succession, we feel a flicker of that ancient fear. But here, in September 2025, fear gave way to something subtler, curiosity sharpened to a knife's edge. The data streams pouring in from observatories told astronomers they were living through a moment they would study for the rest of their lives. From Hawaii to Chile, from amateur backyard setups to the world's most powerful instruments, telescopes turned skyward to trace these visitors. Each one was catalogued, tracked, assigned a designation, folded into the spreadsheets of orbital mechanics. Yet the sense of the uncanny, the feeling that this was not just business as usual, never left. At the heart of the story stood 3I Atlas. Officially named C divided by 2025 N1, it was spotted on July 1st by the Atlas survey team in Chile. At first glance, it was nothing remarkable, another fuzzy dot moving against the stars, but mathematics quickly stripped away the illusion of ordinariness. Its orbit was hyperbolic, an unmistakable signature that this was no native of our solar system. It had come from elsewhere, perhaps light years away, and would never return. That fact alone would have been enough to elevate it above the noise of September's traffic. But it wasn't just its path. Soon, whispers spread that its chemistry defied expectation, that it carried signatures unknown among local comets. By autumn, its reputation had already outgrown its visibility. It was more than a comet. It was a message in motion, a messenger from beyond the sun's dominion. And so September became something more than a busy month for astronomy. It became a test of perception. Were these converging objects a cosmic coincidence, or were they linked, strands of a larger tapestry we had only begun to glimpse? The asteroids and comets were the opening acts, dazzling in their own right, but the star performer, 3I Atlas, still waited in the wings, preparing to step forward into the blaze of perihelion. This is where our story begins, with a world looking up, caught between science and myth, probability and pattern, as the sky above us turned restless. The first act opened with the arrival of a mountain-sized rock, a reminder that even in the quiet of September, Earth's place in the cosmos is never guaranteed. Mid-September 2025 was meant to be quiet. Astronomers expected little more than routine asteroid passes. the kind so common they barely earn a footnote in the nightly logs of observatories. But the universe had other plans. Instead of silence, a cascade began, an asteroid wave that seemed less like random celestial traffic and more like a carefully staged performance. The first headliner was Asteroid 2025 FA22, a mountain-sized mass of stone and silence. Measuring somewhere between 130 and 290 meters across, it was large enough to level a region the size of a small country, if fate had shifted its orbit just slightly. On September 18, it swept past Earth at a distance of just over 2 lunar distances, about 835,000 kilometers away. Astronomically speaking, that's close enough to count as a near miss. For newspapers, it was close enough to print dramatic headlines. For the average person, it was close enough to glance at the stars with a shiver before returning to everyday life. But astronomers knew better. They understood what a rock like FA22 carried. Not just mass and momentum, but raw energy. At over 10 kilometers per second, the asteroid's kinetic force was the equivalent of 100 million tons of TNT, thousands of times the destructive power of the Hiroshima bomb. And yet it passed harmlessly by, a silent reminder that civilization lives under a dome both fragile and thin. What startled the scientific community wasn't FA22 itself, but the company it kept. This wasn't a lone traveler, a solitary rock making its scheduled crossing. It was more like the opening act of a procession. Just 3 days earlier, on September 15, a smaller near-Earth object, 2025 RJ2, had already brushed past. At 0.78 lunar distances, or roughly 300,000 kilometers, it came close enough to make the Moon itself feel like a shield. In cosmic terms, it was practically a handshake, and these weren't isolated incidents. Throughout that week, dozens of small bodies entered Earth's neighborhood, each one tracked and catalogued by the global network of observatories. Normally, this is the quiet work of science: numbers, orbits, risk assessments, the slow accumulation of data. But the clustering gave it a different tone. It felt choreographed, as though the sky itself had conspired to send a fleet our way, each object stepping into view just as the last departed. The sense of performance wasn't just imagination. Humanity has always seen patterns in the heavens, sometimes real, sometimes imposed. Ancient Greeks read destiny in planetary alignments. Polynesian navigators used star paths as guides across an ocean without maps. In September 2025, professional astronomers, people trained to strip away superstition, felt a whisper of that same pattern hunger. Why here? Why now? Was this wave an artifact of better detection, the gift of new observatories like the Rubin's first surveys? Or was there a deeper gravitational reason, something written into the mechanics of the solar system itself? The timing raised uncomfortable thoughts. If FA22 had been on a collision course instead of a harmless flyby, would we have had enough warning? Would planetary defense systems have reacted in time? Or would September 2025 have been remembered as the month an unexpected asteroid rewrote human history? The clustering forced scientists to consider not just one asteroid at a time, but the possibility of multiple threats arriving in concert, overwhelming the fragile architecture of planetary defense. Yet, for all the unease, there was also awe. Each asteroid carried its own biography, billions of years old, fragments of the solar system's earliest days when planets were forming and colliding. To study them is to touch the dawn of our world, to trace the fingerprints of chaos that sculpted Earth itself. In a single week, September brought dozens of such emissaries within reach, each one a time capsule of stone, whispering the story of creation. But just as audiences began to grasp the drama of these asteroids, the sky prepared its next act. A comet, with its luminous tail and ancient symbolism, was already brightening on the horizon, ready to steal the spotlight. The stage was no longer Earth's alone. It belonged to the cosmos, and the play had only just begun. FA22 was not alone. That became clear almost immediately. The days around its flyby did not feel like an isolated event, the kind that astronomers record, analyze, and then shelve into the archives. Instead, it felt like curtain time at a crowded theater. One performer exited stage left, only for the next to step into the spotlight. September 15 had already seen the smaller object, 2025 RJ2, skim past Earth at just 0.78 lunar distances. A brush so near it was as if the Moon had a companion ghosting its orbit. Within hours of FA22's passage, additional objects arrived, Some were small, little more than house-sized boulders, but they came in numbers that were difficult to dismiss. Several passed within sublunar distances inside the span between Earth and Moon, that fragile margin we often imagine as our protective moat. By the week's end, the tally read less like a routine watch list and more like a guest roll call at an opening gala. For the men and women watching through telescopes, the feeling was eerie. Each new discovery sparked urgent calculations, orbital models refined in real time. Normally, such data is detached, almost mechanical, coordinates, distances, uncertainties. But now the pattern was impossible to ignore. Object after object, strung like beads along a thread, weaving their trajectories through our corner of space. It was as though a celestial clock had struck an unseen hour, summoning these wanderers to gather together. Was this truly a pattern, or only an illusion born from human minds evolved to detect them? The question echoed through observatories and conference calls. History offers a cautionary tale. We have always sought meaning in the clustering of stars. The Babylonians charted omens in planetary alignments, convinced they foretold the fates of kings. The Maya read the sky with mathematical precision, believing cycles of Venus signaled times of war. And even now, with equations instead of auguries, astronomers are not immune to the ancient pull of seeing choreography where there may be only coincidence. But something about September 2025 gnawed deeper. One could blame the surge on improved technology. The Rubin Observatory had only recently opened its vast eye to the sky, capturing thousands of faint asteroids previously invisible. Yet the timing felt uncanny. A burst of objects all at once, aligned with the arrival of a newly discovered interstellar visitor, and crowned by the appearance of a brightening comet. The stage seemed too crowded for chance. Amid the unease was also a sense of wonder. These visitors were relics, survivors of creation's earliest violence. Each asteroid was a shard of an ancient collision, a leftover stone from the unfinished architecture of planets. To glimpse so many in succession was to be flooded with reminders of the solar system's restless youth, when worlds grew not through calm accretion but through endless impacts. In a single week, the sky offered a compressed retelling of that violent history. The public, meanwhile, absorbed the drama differently. News outlets framed it as a parade of rocks or a celestial traffic jam. Amateur astronomers flooded social media with sketches and telescope images, adding to the sense that something larger was unfolding. Humanity, in a strange and ancient way, became audience once again, watchers of a play written not for us, but for the cosmos itself. Yet, the true spectacle had only just begun. The asteroids, for all their menace and mystery, were only the first act. Waiting behind the curtain was a comet, luminous and unpredictable, ready to seize the imagination in a way no anonymous rock could. If the asteroids were the drumroll, the comet was the fanfare. While asteroids drew headlines with their raw, silent menace, something far older and more theatrical prepared its entrance in the western sky. A comet. Unlike the anonymous rocks catalogued with sterile designations, comets have always stirred human imagination. They carry tales like banners unfurled, luminous wounds cut into the night, reminders that the universe is alive with motion and fire. And in September 2025, one such visitor, Comet C, divided by 2025 R2, soon nicknamed Swan, began to rise from obscurity into the role of celestial spectacle. It was discovered on September 11th, not by an instrument designed to hunt comets, but by chance. The solar wind anisotropies instrument, SWAN, aboard the SOHO spacecraft, had one job: mapping hydrogen emissions from solar wind interactions at the edge of our system. Yet, in its data, astronomers saw something unexpected. A plume of hydrogen outgassing from a fresh comet falling inward toward the Sunday Swan, by accident, had become a comet finder. That was part of the magic. Comets are emissaries of chaos, often found not by deliberate searches but by instruments that stumble upon them, betrayed by their chemistry. For Swan, it was hydrogen water vapor, splitting under sunlight into atomic fragments detectable from millions of kilometers away. The comet announced itself not by light, but by breath. By mid-September, amateur astronomers were already whispering of sightings. Under rural skies, far from city glare, the comet hovered near Virgo, its faint glow brushing shoulders with the bright star Spica and the reddish spark of Mars. At magnitude 6, it sat at the edge of naked eye visibility, demanding patience and darkness to reveal itself. Through binoculars, Its coma glowed with a ghostly green tint, and a tail stretched outward like a brushstroke across twilight. It was a fragile beauty. Comets are not like asteroids, carved from rock and iron. They are dirty snowballs, loosely bound, fragile to the point of absurdity. Their surfaces crack, vent, and fracture as they fall sunward. Swan might not survive. Many comets perish in their first true encounter with the sun, breaking into shards, leaving only streams of dust and gas that drift into meteor showers. Observers knew the risks, but that made the sight more precious beauty on the verge of annihilation. Humanity has always feared and worshipped comets in equal measure. The Bayeux Tapestry depicts Halley's comet above the battlefield of Hastings in 1066, as soldiers whisper that it portends the fall of kings. Chinese dynastic records describe them as broom stars, sweeping away emperors' reigns. Even in modern times, comets retain that aura. Hale-Bopp in 1997 became a global event, its long, luminous tails drawing millions into night fields. For many, Swan stirred echoes of that old awe, but for astronomers, Swan was not merely a spectacle, it was a laboratory. Its coma and tail carried volatile materials locked away since the birth of the solar system. Observing its chemistry offered glimpses into a time before Earth had cooled, before oceans filled, when icy wanderers like Swan may have delivered water and organics to a barren planet. In this fragile green torch flickering in the night, scientists saw the origins of oceans and, perhaps, of life itself. As Swan brightened through September, it added another layer to the growing sense of cosmic theatre. Asteroids swept past in waves, and now a comet glowed in twilight, visible to anyone with the patience to look. It was as if the universe itself were staging a performance, rocks as drums, comets as flutes, building toward the arrival of an interstellar note unlike any yet heard. The audience on Earth, willingly or not, had become part of the play. Some saw danger, some beauty, others opportunity, but all could feel that September was no longer ordinary. The sky had opened, and its performers had only begun to take their places. Even as comets brightened and asteroids swept by, another presence loomed in the background. Its name was already infamous, Apophis. Officially designated 99942 Apophis, this half-kilometer-wide mountain of rock had once been at the very top of planetary defense watch lists. For years, headlines warned that it might strike Earth in 2029. Astronomers calculated probabilities, journalists coined dramatic nicknames, and the public, for a time, allowed itself to imagine what the end of the world might look like. By September 2025, the calculations had improved. The danger of impact was ruled out for at least a century, yet that reassurance did not soften the sense of awe or unease that Apophis carried with it, because certainty of safety is not the same as comfort. Its flyby in April 2029 would bring it just 32,000 kilometers above Earth's surface, closer than many satellites. Imagine standing outside and watching a star streak across the sky faster than a bullet, brighter than most planets, knowing it is a mountain-sized stone racing by at 50,000 kilometers per hour. Apophis was no longer a harbinger of destruction, but it remained a spectacle unlike anything humanity had ever seen. The very name Apophis hints at why the asteroid captured public imagination. Named after the Egyptian serpent god of chaos, enemy of the sun, it embodies the tension between order and catastrophe. Ancient myths gave shape to humanity's fear of the unpredictable heavens. In naming this asteroid after such a figure, astronomers unintentionally resurrected that tradition. Even as orbital mechanics assured us of safety, myth whispered of danger. For scientists, however, Apophis represented opportunity. Its passage so near to Earth meant tidal forces would sculpt it in real time. Landslides might sweep across its surface, loose boulders could tumble, its very rotation could change, forever altering its face. In April 2029, Apophis would become a natural laboratory, a before and after experiment conducted on a scale no spacecraft could hope to replicate. NASA had already prepared. The OSIRIS-APEX mission, a repurposed sibling of the OSIRIS-REx probe, was en route, tasked with observing Apophis in the aftermath of its Earth encounter. The importance of this close passage cannot be overstated. For decades, planetary defense has been a field of probabilities and simulations, but Apophis promised something rare: direct evidence. Scientists would see how a large asteroid behaves when Earth itself becomes the experiment, exerting forces that reshaped an ancient rock before human eyes. What we learned from Apophis might one day determine how we nudge or deflect others like it. Yet for all its scientific promise, Apophis was a ghost at the feast of September 2025. Every mention of comets or asteroids carried its shadow, the unspoken reminder that one day, perhaps not in 2029, but someday, one of these wanderers will not pass harmlessly by, one will not miss. And when that happens, it will no longer be a spectacle, but a reckoning. As Swan brightened in Virgo and FA22 drifted safely past, Apophis loomed in the collective imagination as the ultimate what if. The cosmos was performing, yes, but Apophis was the stage prop no one could ignore, waiting in the wings, reminding the audience that this play was not just entertainment, it was a rehearsal for survival. For all the drama of September, the asteroids in clusters, the brightening comet, the looming shadow of Apophis, none of it could overshadow what astronomers quietly whispered about in their reports. Hidden among the daily discovery announcements was something without precedent, something that seemed to defy the familiar boundaries of our solar system. It was called 3I Atlas, formerly catalogued as C divided by 2025 N1, discovered on July 1, 2025, by the Atlas survey team in Chile. It first appeared as just another faint, fuzzy dot drifting against the stars. Automated software flagged it, telescopes followed up, and astronomers began plotting its orbit. That is where the ordinary ended. The numbers told a story unlike any asteroid or comet discovered that summer. Its orbit was hyperbolic, an open curve, not a closed loop. In the language of celestial mechanics, that meant one thing: this object was unbound. It had not been born of the sun's gravity, nor would it ever be captured by it. It had come from somewhere else, another star system, perhaps light years away, and after its brief passage, it would vanish again into the dark. This made 3I Atlas only the third confirmed interstellar object ever detected, following the mysterious, cigar-shaped Oumuamua in 2017 and the cometary 2I Borisov in 2019. But unlike its predecessors, this visitor arrived at the perfect time. Our instruments had evolved, our telescopes had sharpened, our networks of observers had expanded. Humanity was better prepared than ever before to witness such an encounter. Yet what elevated Atlas beyond a mere curiosity was not only its path but its timing. Its perihelion, the closest swing around the Sun, was set for late October 2025, mere weeks after the September surge of asteroids and comets. Then, in December, just as Earth shifted into the right vantage point, Atlas would re-emerge from solar glare. At that moment, telescopes across the world, ground-based, orbital, and even the mighty James Webb, would be poised to capture it. The window was ideal, not so close as to endanger Earth, yet not so far as to escape detailed scrutiny. For astronomers, it felt like the universe had delivered a gift, a carefully wrapped sample of alien chemistry, presented at the very moment when humanity had the tools to open it. Too perfect, some said, almost staged. Atlas was not a silent stone like FA22. Early observations hinted at activity, a developing coma, signs of outgassing, a whisper of a tail. Unlike Oumuamua, which baffled scientists by refusing to behave like either comet or asteroid, Atlas seemed willing to show its nature. It was a comet from the stars, a body that had traveled for perhaps billions of years through the interstellar dark, carrying in its ices and dust the fingerprints of a world we would never otherwise see. But with that promise came questions. Why now, in the very season when our skies were crowded with asteroids and comets, did an interstellar visitor choose to arrive? Was it pure coincidence, the randomness of cosmic traffic finally noticed by our improved instruments? Or was it part of something larger, a convergence we had not yet learned how to read? For the first time, astronomers spoke openly not of fear, but of profound curiosity. If Atlas was what it appeared to be, then we were not merely studying another object. We were peering into another solar system, another history, another way of building worlds. And that possibility was staggering. September had been a performance of asteroids and comets, but now, the true star was on its way to center stage, an interstellar intruder carrying secrets that might reshape how we see not only our solar system, but our place in the galaxy itself. The deeper astronomers studied 3I Atlas, the more uncanny its timing appeared. It was not simply an interstellar visitor rare enough on its own, but one that arrived with a schedule so fortuitous, it felt almost designed. Its perihelion, the moment of closest approach to the Sun, would occur on the 30th of October 2025. Just weeks after the asteroid wave and comet Swan had drawn the public's gaze upward, Atlas would make its own entrance. But unlike the fleeting flybys of FA22 or the fragile unpredictability of Swan, Atlas carried with it a kind of patience. After disappearing briefly into the blinding glare of the Sun, it would re-emerge in December, perfectly positioned for telescopes across the world to study. And not just any telescopes. This was the era of astronomical renaissance. The Vera C. Rubin Observatory, newly commissioned, was sweeping the skies with unmatched speed. The James Webb Space Telescope, with its infrared gaze, was poised to dissect Atlas's chemical signature. Ground-based giants like the Very Large Telescope in Chile and Keck in Hawaii stood ready to capture its evolving coma and tail. Even amateur astronomers, armed with sensitive digital equipment, would be able to contribute. The geometry was ideal. At closest approach in December, Atlas would be about 1.88 astronomical units away, roughly 270 million kilometers, far enough to pose no threat, but close enough for detailed study. The object would shine in the pre-dawn skies, high enough for clarity, far enough from the Sun's interference. For planetary scientists, it was as if the cosmos had pulled back a curtain, revealing a stage set with perfect lighting and acoustics, and then placed on it a relic from another world. Too perfect, some whispered. In the halls of conferences and the margins of papers, speculation bubbled. Was this merely luck, the inevitable product of improved survey technologies, or was there something in the mechanics of the galaxy itself, some gravitational river that guided these interstellar objects to pass near inhabited worlds like ours? It was a dangerous thought, too close to teleology for comfort, yet difficult to ignore. The timing also struck a chord in human imagination. Cultures across history have looked for meaning in the heavens' choreography. When comets appeared alongside eclipses, kings fell. When planets aligned, prophets wrote of destiny. And now, in an age supposedly immune to superstition, the same question lingered. Why now? Why this interstellar messenger, arriving amid a storm of comets and asteroids, precisely when our species had finally gained the tools to study it? In truth, the answer may be simple: chance. The galaxy is filled with debris, ejected by newborn planetary systems over billions of years. Interstellar space may be littered with objects like Atlas, passing unseen until the right instruments catch them. Yet knowing that did little to quiet the sense of awe. For even if it was mere chance, it was chance weighted by billions of years of history, by physics and probability, aligning in a way that made it feel personal. Atlas's approach was a promise. It offered not just data, but perspective. This was matter forged in another star's nursery, wandering through the void before Earth itself had cooled, now arriving at our doorstep for us to examine. It was not a threat, not a herald, but a delivery carefully timed, uncannily convenient. A message from the galaxy, sealed in ice and dust, waiting to be opened. The stage had never been so perfectly set. But as astronomers prepared their instruments, a darker thought lingered. If chance could deliver us such a gift, it could also deliver disaster. FA22 had passed harmlessly by, but what if it had not? What if one of the September rocks had carried a different trajectory? The same window that brought us Atlas could just as easily have brought an ending. And so the story of 3I Atlas was not just about discovery. It was about fragility, about the thin line between wonder and catastrophe, and about what it means to live in a universe where the cosmos sometimes feels like it is speaking directly to us. Asteroid 2025 FA22 passed harmlessly by on September 18th, no more than a headline and a fleeting blip on astronomers' screens. But beneath the calm tone of official reports, one question lurked in every calculation. What if it hadn't? What if the orbit had shifted just slightly, and FA22 had been on a direct collision course with Earth? The mathematics of such an impact are merciless. FA22, measuring between 130 and 290 meters across, carried kinetic energy equivalent to roughly 100 megatons of TNT. To place that in human terms, that is about 2,000 times the destructive force of the Hiroshima bomb, compressed into a single descending rock, enough to obliterate a city, flatten entire regions, or trigger tsunamis that would redraw coastlines. The details, as always, depend on luck or lack thereof. A stony asteroid of that size entering Earth's atmosphere at nearly 11 kilometers per second would ignite the sky like a second sundae. Friction would compress and heat the air ahead of it into plasma, a white-hot sheath glowing across hundreds of kilometers. At altitudes between 5 and 15 kilometers, pressures could overwhelm the asteroid's structure, causing it to explode in a blinding airburst. History gives us a precedent. In 1908, over the Siberian taiga, a much smaller object, perhaps 50 meters across, detonated in the atmosphere above Tunguska. The blast flattened over 2,000 square kilometers of forest, equivalent to a modern metropolis wiped clean in seconds. FA-22, many times larger, would dwarf that destruction. Imagine it. At 200 kilometers from ground zero, a flash brighter than the sun would sear the sky. Exposed skin would burn instantly. The thermal pulse would ignite forests and fields. Then would come the shockwave air compressed into a wall of force, shattering windows and leveling buildings out to distances of 50 kilometers or more. Even well-constructed concrete structures might collapse under the overpressure. If FA-22 were denser iron instead of stone, or if its entry angle allowed it to survive deeper into the atmosphere, the outcome could be worse. A ground impact would gouge a crater nearly 3 kilometers wide, ejecting millions of tons of vaporized rock into the sky. Seismic shockwaves would ripple outward like a magnitude 6.5 earthquake, shaking cities hundreds of kilometers away. Fires, ash, and falling debris would compound the devastation. And then there is the ocean scenario, the most statistically likely outcome, given that water covers over 70% of Earth's surface. Here, the danger would not be fire, but waves. An asteroid plunging into the Atlantic would hurl up walls of water over 100 meters high at the impact site. Those waves would spread outward at the speed of a jet aircraft, still towering meters high by the time they reached distant coasts. Hours after impact, tsunamis could batter cities from Boston to Barcelona. The loss of life would depend on evacuation warnings, but the economic and cultural scars would last generations. Yet, FA-22 was not large enough to threaten the planet itself. Civilization would stagger, perhaps millions would die, but humanity would endure. True global extinctions are the work of kilometer-sized monsters, the kind that strike only once in many hundreds of thousands of years. What makes objects like FA-22 so chilling is not their rarity but their frequency. They are common enough to be called city killers, lurking in the statistical shadows of our detection networks. The Chelyabinsk event of 2013 was a brutal reminder. A 20-meter asteroid, unseen until the moment it arrived, exploded over Russia with the force of 500 kilotons of TNT. Windows shattered, buildings shook, and over 1,500 people were injured, mostly by flying glass. Chelyabinsk was a tenth the size of FA-22, a fraction of the energy, and still, it caused chaos. FA-22's safe passage, then, was more than good fortune. It was a rehearsal, a warning wrapped in relief. For planetary defense agencies, the event became a live fire test of global coordination. Risk assessments were drafted, updated, and dismissed as new data refined its orbit. The world briefly held its breath, and then exhaled. But the question lingered. Would we be ready next time? Because there will be a next time. The cosmos does not run on our schedules. It cares nothing for the fragility of cities or the hopes of civilizations. Asteroids pass near Earth every month. Most are harmless, a few are close enough to unsettle, and someday, one will not miss. That is the truth FA-22 left behind in its wake, that survival is a matter of vigilance, of preparation, and of time. And that in September 2025, we were lucky. Luck cannot be strategy. FA-22's safe passage might have calmed headlines, but for scientists and defense agencies, it was a fire drill on a planetary scale. In those tense days, the asteroid briefly appeared on Europe's official risk lists before refined calculations erased it again. To the public, this came and went as a curiosity. But inside the control rooms of agencies like NASA, ESA, and JAXA, it was a live simulation. What if the data had tipped the other way? Planetary defense is not science fiction anymore. It is a field of international coordination, precision mathematics, and hardware already tested in space. The most famous proof came just 3 years earlier, in 2022, when NASA's DART mission slammed a spacecraft into the small asteroid Dimorphos. The collision shortened its orbital period around its larger companion by 32 minutes, far more than the 4 minutes needed for success. The result was undeniable. Humanity had nudged a celestial body for the first time in history. We had played billiards with the cosmos, and won. But Dart was only the first move. The European Space Agency's Hera mission is already on its way, scheduled to arrive in 2026, to survey the aftermath in exquisite detail. Hera will map the crater, measure the rubble ejected, and tell us how kinetic impacts truly work across different asteroid types. For in planetary defense, details matter. A solid iron mass responds differently than a loose rubble pile. Strike the wrong way, and you risk shattering the target into fragments, each one still on a collision course. FA-22 brought these questions out of the theoretical and into the urgent. Its flyby forced global coordination. Observatories across continents shared tracking data in near real time, testing the protocols of the International Asteroid Warning Network. Governments rehearsed their lines: how to inform the public without sparking panic, how to handle uncertainty when a rock's path still has wide margins of error. The system worked, but gaps remained. Glaring ones. The largest gap is the sunward blind spot. Ground-based telescopes cannot see objects approaching from the direction of the Sunday. That was how the Chelyabinsk meteor slipped through in 2013, arriving undetected until it exploded above Russia. Even city-killer asteroids hundreds of meters wide can hide there, invisible until hours before impact. FA-22 did not emerge from that corridor, but what if it had? That is why eyes now turn to space-based observatories. NASA's upcoming NEO Surveyor, set for launch in 2027, is designed to watch in infrared from an orbit trailing Earth, able to peer into the blinding direction we cannot see from the ground. Once operational, it will close the most dangerous hole in our defenses. Until then, the blind spot remains. FA-22 was a gift, harmless enough to let us breathe, close enough to make us test ourselves. It reminded us that planetary defense is not about dramatics or doomsday prophecies, it is about preparedness. The earlier we see a threat, the gentler the solution. A tiny nudge applied decades in advance can save us from catastrophe, delay, and the options shrink to desperation. The September surge underscored the reality: the universe is not empty, and Earth is not alone. Our planet sails through a shooting gallery of cosmic debris. Most of it is dust, harmless meteors that burn in streaks of light, but sometimes larger pieces arrive. FA-22 was one of them. The next may not be so forgiving, and so planetary defense remains less about fear than responsibility. It is the discipline of vigilance, the discipline of humility. For all our technology, all our progress, we remain fragile beneath the heavens. Survival requires more than luck. It requires watching, preparing, and acting before the cosmos decides for us. If asteroids stir fear with their blunt violence, comets stir something deeper, more ancient, a mixture of awe and foreboding. September 2025 was not only the month of FA-22 and its rocky companions, it was also the month when comets seemed to multiply, each one painting a new stroke of light across the night sky. First came Comet Swan, its fragile green coma glowing faintly in Virgo, but it was not alone. By mid-September, astronomers reported a curious clustering. As many as 7 comets were visible within the span of just a few weeks. Some were faint, others brighter, but together they created a sense of celestial abundance rarely seen in modern times. For amateur skywatchers, it was a gift. For scientists, it was a puzzle. Comets are capricious things. They flare, they fragment, they vanish. Predicting their brightness is notoriously unreliable. One comet may erupt into brilliance far exceeding forecasts, while another, with great fanfare, dissolves into dust before reaching the naked eye. September's cluster reminded everyone of this unpredictability. It felt less like a set of independent arrivals and more like a chorus, different voices singing variations on the same theme. To the human imagination, comets have always carried weight far beyond their physical presence. In medieval Europe, their sudden appearance was read as divine judgment, heralding plagues, wars, or the deaths of rulers. The chronicles of 1066 record Halley's comet blazing above England, just as William the Conqueror prepared his invasion. In China, court astronomers kept meticulous records, fearing the emperor's wrath if they failed to read the broom stars correctly. Even Shakespeare gave them lines. When beggars die, there are no comets seen. The heavens themselves blaze forth the death of princes. Even today, When we know their composition, dirty snowballs of ice and dust, the symbolism lingers. They arrive unbidden, unpredictable, as though carrying messages from the edges of the solar system. Their very fragility, flaring to life near the sun, then dissolving into nothing, makes them seem more like omens than objects. In September 2025, with comets appearing in clusters, that old instinct reawakened. News outlets framed it as a comet storm. Social media filled with photographs, streaks of faint light over city skylines, greenish smudges over dark fields. For many, it felt like being pulled back into the mind of ancient ancestors, reminded that the heavens are not static but alive, capable of surprise. For astronomers, the surge was less mystical, but no less important. Each comet carried a frozen archive of the early solar system, a chemistry older than Earth itself. By studying their comas and tails, scientists could measure the ratios of water isotopes, the presence of carbon compounds, the fingerprints of materials that may have seeded Earth's oceans, and even life. To see several comets at once was to receive multiple test samples from the dawn of time, delivered simultaneously. And yet, the emotional weight mattered as much as the data. The clustering of comets, combined with the asteroid wave and the looming promise of 3I Atlas, created the sense that September was not just busy, it was extraordinary. The sky itself seemed to lean toward us, insisting we pay attention. Asteroids had tested our defenses, comets tested our imaginations, and together they prepared the stage for the interstellar visitor, still on its way, the messenger from beyond the sun, carrying secrets stranger than either rock or ice could hold. As September's comets flared and faded, astronomers turned their attention back to the deeper enigma, 3I Atlas. Unlike FA-22, it was not a brute of stone. Unlike Swan, it was not a fragile local wanderer. Atlas was something else, an emissary from another star. And in its faint light, scientists glimpsed an opportunity to read chemistry not of our solar system, but of another. Every comet carries with it a frozen library. Locked in its ices are molecules preserved since the dawn of time. When sunlight warms the surface, those ices sublimate into gas, creating the glowing coma and streaming tail. That gas, when analyzed with spectrographs, becomes a language, a set of spectral lines, revealing what the comet is made of. For solar system comets, the vocabulary is familiar: water, carbon dioxide, carbon monoxide, methanol, ammonia, organics of various kinds. But Atlas came from beyond the sun's reach. Its chemistry promised to be a dialect we had never heard before. Early data hinted at peculiarities: the ratios of carbon monoxide to carbon dioxide, the strength of hydroxyl bands, the presence of exotic nitriles, all appeared unusual compared to local standards. Some scientists cautioned that it was too early to declare anomalies. After all, comets vary widely even within our own system. But the whispers spread. Perhaps Atlas carried the fingerprints of a planetary nursery different from our own. To appreciate the significance, one must imagine what these molecules represent. They are the building blocks of worlds. The water in Earth's oceans may have come from comets like these. The carbon compounds in our own biology could trace their origins to icy bodies that struck a young Earth billions of years ago. If Atlas's chemistry differed, it meant that elsewhere in the galaxy, planets and life may have started from different recipes. The thought was staggering. For the first time, we could compare the raw ingredients of another solar system to our own. It was as if a fragment of a distant kitchen had drifted into our pantry, allowing us to taste the flavors of a world we would never visit. And beyond science, the implications stirred imagination. If Atlas carried molecules rare or absent here, could those be the seeds of alien biology? Could life, elsewhere, be built not on the same foundation of carbon-water chemistry we know, but on something stranger? Atlas was not just a comet. It was a messenger carrying a chemical note written in the hand of another star. Spectrographs across the world trained on it. JWST prepared its infrared instruments. The Rubin Observatory logged its trajectory night after night. Even amateurs began to contribute, their small telescopes adding to the collective watch. The excitement was not about brightness, it was about composition. For once, light itself was the treasure. In September 2025, humanity found itself not just looking outward, but inward. The chemistry of Atlas forced us to ask, how universal is life? How narrow, or how broad, is the path from dust to biology? The answer would not come all at once, but in spectral lines, in ratios, in subtle differences that spoke across light years. Atlas was still approaching, still weeks from its moment in the spotlight. Yet already it had done something profound. It had reminded us that our solar system is not the template, only one example, that in the vastness of the galaxy there are other stories, other chemistries, other beginnings, and for the first time, one of them had come to us. Atlas might have been just another comet with exotic chemistry, a scientific curiosity destined to pass and fade. But then came the strangeness, the behaviors that seemed to defy expectation. To astronomers, it was not the object's size or brightness that unsettled them, but its motion. At first, everything fit the textbook. A hyperbolic orbit, inbound from interstellar space, arcing past the sun before retreating again into the dark. But as data accumulated, small deviations emerged. Its trajectory was not a perfect mathematical curve. Tiny accelerations nudged it outward, beyond what gravity alone could explain. This was not unprecedented. Comets often misbehave. As sunlight warms their surfaces, jets of gas burst from vents, pushing them like microscopic thrusters. The effect is subtle but measurable non-gravitational accelerations that complicate orbital predictions. Yet with Atlas, the pattern felt odd. The jets seemed stronger than expected. At times, they flared asymmetrically, pushing the object in ways that didn't align neatly with solar heating. The déjà vu was unmistakable. Astronomers recalled the debates around Oumuamua in 2017, the first interstellar visitor. It too had shown unexplained accelerations, moving as if pushed by an invisible hand. Some had argued it was a fragment of hydrogen ice, others a thin sheet propelled by sunlight, still others controversially that it might be artificial, a probe or a relic of alien technology. The mainstream consensus leaned toward natural explanations, but the unease lingered. And now, in 2025, Atlas revived those whispers. Even its rotation seemed peculiar. Early photometric studies suggested it might be tumbling chaotically, wobbling in a way that resisted easy modeling. Comets do tumble, of course. They are irregular, fractured, spinning from uneven outgassing. But the complexity of Atlas's light curve, with its unpredictable flickers, suggested a geometry stranger than the usual potato-shaped nucleus. Some speculated it might even be elongated or fractured, a cluster of fragments loosely bound, masquerading as one. To the public, these details were invisible, arcane arguments buried in technical papers. But among scientists, the mood was split. Some insisted Atlas was simply another comet, albeit an unusually vigorous one. Others saw the echoes of Oumuamua, too sharp to ignore. The phrase uncanny began to circulate in conference chatter, not proof of anything unnatural, but an acknowledgement that Atlas was playing at the edges of what we understood. And then there was the timing. Atlas arrived in the very month Earth was crowded with asteroids and comets, as if part of a larger celestial choreography. Rationally, there was no connection, yet the human brain, wired to see patterns, could not resist weaving a story. Was this coincidence? Or did Atlas represent something more, an interstellar seed cast among a storm of local debris, a messenger traveling not alone but as part of a cosmic tide? For now, astronomers resisted the leap. They focused on data, refining orbital models, measuring jets, preparing instruments for the December window when Atlas would be brightest. But the unease remained, unspoken, yet palpable. For if Atlas truly behaved unlike any comet before it, then the implications were profound. In the quiet hours of observatories, one thought repeated itself. Perhaps we are being shown something we do not yet know how to interpret, something the universe is whispering, line by line, in the strange, shifting path of a comet from the stars. No sooner had Atlas's odd accelerations been reported than an old argument reignited, one that had smoldered since 2017, when Oumuamua streaked through our skies. Could an interstellar visitor be not merely natural, but technological? The idea was controversial, almost taboo in some circles. Science thrives on evidence, and extraordinary claims require extraordinary proof. Yet the very strangeness of Oumuamua, its elongated shape, its unexplained push away from the sun, had inspired Harvard astronomer Avi Loeb to propose a bold hypothesis. Perhaps it was artificial, a fragment of alien engineering, a light sail drifting through interstellar space. Most experts rejected the claim, citing natural explanations like volatile outgassing or unusual geometry. But the seed had been planted, and with Atlas, that seed sprouted again. The arguments followed familiar lines. On one side were the skeptics. Comets misbehave, outgassing is messy, data is noisy. There is no need to invoke aliens when physics suffices. On the other side, a minority argued that coincidences pile up. The uncanny timing of Atlas's arrival, the odd non-gravitational forces, the possibility of unusual structure. Was it truly impossible that a civilization somewhere in the galaxy might send out probes, whether deliberately or as ancient debris that occasionally wander into our skies? For the public, the debate was electrifying. Headlines framed it as comet or alien craft. Talk shows speculated wildly. Social media filled with renderings of silver sails, derelict starships, and gleaming monoliths disguised as comets. Even those who doubted the alien hypothesis couldn't help but feel a thrill at the thought. What if? Scientists, meanwhile, walked a narrow line. Some worried that even entertaining the idea undermined credibility, inviting mockery and conspiracy. Others countered that science must not shy from uncomfortable possibilities. After all, if interstellar probes did exist, ignoring the evidence would be the greater failure. The truth was, Atlas gave little to work with. Its spectrum suggested ices and dust, not alloys or machinery. Its light curve hinted at irregularity, not symmetry. It looked, in most respects, like a comet, and yet the odd behaviors lingered, nagging like a splinter in the mind. Not proof, but provocation. Philosophers reminded us of perspective. For centuries, humanity believed comets were omens of gods and kings. Then we learned they were natural. Perhaps, one day, we will learn that some are artificial after all. Or perhaps we are seeing only the shadows of our own imagination, cast against the canvas of the stars. What Atlas truly represented remained uncertain. But one thing was undeniable. It forced us to ask questions larger than itself. Questions about our place in the galaxy, about whether intelligence might echo beyond our skies, about whether messengers sometimes arrive not by chance, but by design. And even if Atlas was nothing more than frozen dust, its effect was real. It reignited the debate, sharpened curiosity, and reminded us that the line between science and wonder is not a wall, but a bridge. Even without speculation about alien technology, Atlas was already extraordinary. What mattered most was not what it might be, but where it had come from. This was not just a comet from another star. It was a fragment of deep time, a survivor of galactic history older than our Sunday. To grasp its significance, imagine the birth of a distant star system billions of years ago. In those chaotic early days, planets formed by colliding and coalescing from disks of dust and ice. Some bodies grew large, others remained small. Many were thrown outward by the gravitational violence of giant planets. Ejected, exiled, they became wanderers of interstellar space, frozen remnants carrying the chemical fingerprint of their home. Atlas was one of them. For ages beyond comprehension, it drifted, not for centuries or millennia, but for millions, perhaps billions, of years. Alone, frozen, untouched by any star's warmth. Through the dark gulfs between stellar neighborhoods, past drifting clouds of hydrogen and dust, perhaps through the faint tides of the galactic spiral arms, Atlas journeyed. If comets in our own solar system are time capsules of the solar nebula, then Atlas was a time capsule of another sun's birth, an ancient echo from a family of worlds we will never see. When astronomers looked at it, they were not merely studying an object. They were studying history on a cosmic scale. The ratios of elements in its ices, the structure of its dust, even the shape of its orbit told a story. That planetary systems form everywhere, that ejections are common, that the galaxy is littered with these castaways. For every star you see in the night sky, there may be thousands of Atlas-like fragments wandering between them. And then, by chance or by inevitability, one of those fragments entered our solar system, offering itself to study. For the first time in human history, we could test whether our solar system is typical or unusual. Do other worlds use the same recipe of water, carbon, nitrogen, and organics? Or does Atlas carry a different chemistry, a reminder that Earth's life is only one variation among many? This perspective shifts the debate. Whether natural or artificial, whether comet or probe, Atlas is still a messenger. Its message is time. It tells us that the galaxy is not empty, that it is full of debris and memory, that even across billions of years, small frozen objects can endure. Long after civilizations rise and fall, long after stars swell and fade, fragments like Atlas keep drifting, silent witnesses to everything. The thought is humbling. Atlas had been traveling through interstellar night while Earth's continents were still unformed, while trilobites crawled on Cambrian seabeds, while dinosaurs ruled and perished, while humans learned fire and words. And now, in a blink of cosmic time, it happened to cross paths with a species capable of asking what it was. Atlas was more than a comet. It was a survivor, a relic not just of another solar system, but of the galaxy itself, carrying in its icy body the proof that time stretches far beyond our imagination and that the universe remembers everything. By the end of September 2025, the sky no longer felt like background. It felt like a stage alive with motion asteroids sweeping past, comets glowing and fading, and an interstellar wanderer on approach. For astronomers, it was exhilarating. For the public, it was unsettling. And for all humanity, it was a reminder. We live beneath a sky that is not still, but restless. Most of the time, we forget this. The night sky appears fixed, eternal, the same constellations our ancestors painted on cave walls and carved into temple stones. Yet the reality is far more dynamic. The heavens are a river of objects, large and small, flowing constantly. September had pulled back the curtain, letting us glimpse the river's true turbulence. The message was clear. Earth is not a fortress. It is a target, a fragile world in a cosmic shooting gallery, shielded only by vigilance and luck. FA-22's near pass reminded us of physical vulnerability. The surge of comets reminded us of ancient fear. Atlas reminded us of deep time. Together, they created a tapestry of warnings and wonders, stitched across a single month. It echoed history. In the Middle Ages, comets meant doom, portents of plague or war. In the 20th century, we learned to laugh at such fears, to treat comets and asteroids as curiosities. But September 2025 reopened the question not of omens, but of perspective. These were not signs from the gods. They were signs from nature, reminders of where we stand, small, temporary, and vulnerable, beneath a vast and indifferent cosmos. And yet, in that vulnerability lies power. To see the danger is to acknowledge it. To acknowledge it is to prepare. September forced humanity to look up not just with superstition, but with science. The coordination around FA-22, the study of Swan, the preparations for Atlas, all showed a species learning to read the sky not with fear, but with responsibility. The September sky was not a prophecy. It was a mirror. In its crowded stage of rocks and ice, it reflected our own fragility, our own resilience, our own hunger to understand. It reminded us that survival depends on humility, vigilance, and imagination. And above all, it reminded us that the universe will not wait for us. It will perform its dramas whether we watch or not. The question is whether we choose to pay attention. September 2025 gave us no choice. The curtain had lifted, the performance had begun, and humanity was in the audience watching, learning, and wondering. 3. Atlas was rare, yes, but perhaps not as rare as once believed. When Oumuamua flashed through in 2017, scientists were stunned. No one had ever seen an object from another star. The odds seemed astronomical. Then came 2I Borisov in 2019, a textbook comet but unmistakably interstellar. Now, just 6 years later, 3I Atlas had arrived. 3 visitors in less than a decade. Coincidence or revelation? The answer lay in numbers. With each detection, astronomers refined their estimates. For every interstellar object large enough to be caught by our surveys, there may be trillions smaller, drifting invisibly between the stars. Ejected during the chaotic births of solar systems, they wander forever, unbound, seeding the galaxy with icy fragments. The Milky Way may contain more of these lost wanderers than stars themselves. Atlas, then, was not unique. It was typical. What was unique was our ability to see it. A century ago, it would have passed unnoticed, a ghost slipping silently by. Even in the early 2000s, our sky surveys were not sensitive enough, but by the 2022s, with wide-field telescopes scanning the heavens nightly, our net had grown fine enough to catch such ghosts. The discovery of Atlas was not a miracle. It was the first ripple in a tide of discoveries to come. And yet, scale makes the mystery deeper, not smaller. If trillions of such objects drift through the galaxy, what stories do they carry? Each one is a fragment of another world, another history, another star. Some may bear chemistry similar to ours. Others may be wildly different, carrying compounds never stable in our own system. Together, they form a galactic archive, scattered across the void. The implications ripple outward. Could interstellar comets be natural couriers, spreading organic molecules from system to system? Could they be part of panspermia, the ancient idea that life itself may travel in spores aboard icy rocks, leaping from star to star across eons? If so, then perhaps Earth's life is not an isolated spark, but part of a cosmic fire spreading slowly across the galaxy. And then there is the sobering side. If interstellar debris is common, so too are interstellar threats. An object like FA-22 arriving from beyond could slip past our watch with little warning, moving too fast for deflection, striking with unimaginable force. Planetary defense, already difficult against local asteroids, would be nearly powerless against interstellar ones. The scale reminds us, wonder and danger are always twinned. For now, Atlas was only a visitor, distant, measurable, safe. But its presence redefined what rare means. We are not alone in our solar system. Even when no planets share our orbit, we are surrounded, always, by the slow rain of strangers. Atlas was not an exception. It was the beginning of recognition that the galaxy is alive with wanderers, and Earth is just one stop along their endless roads. By the time September drew to a close, the question could no longer be ignored. Was all this asteroid wave, comet surge, the looming Apophis, and now 3I Atlas mere coincidence? Or was there a deeper pattern hidden within the choreography of the sky? Astronomers, trained to be cautious, lean toward coincidence. The solar system is dynamic, filled with millions of asteroids and comets. New survey telescopes like Rubin simply revealed what had always been there. With sharper instruments, we see more traffic. And when we see more, our minds are quick to string them into stories. The clustering of asteroids in mid-September, statistically possible. The surge of comets, within expected ranges. The arrival of Atlas, a chance alignment in a galaxy teeming with wanderers. But the human mind resists such answers. For millennia, we have looked at the heavens and sought meaning in their patterns. We charted constellations from random stars, drew myths from planetary alignments, saw destiny in eclipses. Even now, in the age of supercomputers, we are not immune to the pull of pattern. And September 2025 seemed too rich with symbolism. First came the silent rocks, threatening but passing us by. Then the comets, fragile messengers glowing like warnings. Then, Apophis, the named serpent of chaos, lurking in the near future. And finally, an interstellar visitor, something from beyond, as if stepping on stage exactly when the curtain rose. Coincidence? Or narrative? The danger lies in overreach. To imagine design where none exists is to slip back into superstition. Yet to dismiss the intuition of patterns is to miss connections. Science itself is the art of finding patterns in noise. The orbit of planets, the chemistry of stars, the structure of galaxies, all once seemed like chaos until the pattern was revealed. Perhaps September was chaos, or perhaps we had glimpsed a structure we do not yet understand. Some suggested gravitational cycles as a natural explanation. Just as Jupiter's pull stirs asteroid families into periodic encounters, perhaps deeper resonances shape waves of comets and asteroids together. Others pointed to sheer probability. In a universe so vast, unlikely things happen all the time, and we only notice the rare coincidences that cluster. Yet, beneath the academic caution, a whisper persisted. What if? What if interstellar objects do not arrive at random, but along unseen rivers carved by galactic tides? What if the clustering of local rocks and foreign wanderers is not chance, but resonance gravity's hidden harmony, playing chords across the solar system? For now, the question remained unanswered. But in September 2025, humanity felt the tension between coincidence and pattern as keenly as our ancestors once did when a comet blazed over their harvest fields. The universe had performed, and the meaning of the performance was left for us to decide. September 2025 was not only a month of spectacle, it was a month of rehearsal. Each asteroid, each comet, each sudden orbit refined by frantic calculations became part of a test that humanity did not schedule but could not ignore. If there was a lesson, it was this: survival is not guaranteed, but it can be prepared for. FA-22 was the headline example. a mountain of rock that missed by just 2 lunar distances, reminded us that the difference between near miss and history-altering catastrophe can be measured in days of orbital drift. The smaller object, RJ2, brushed even closer. These events forced scientists to act out the playbook in real time: discover, confirm, calculate, coordinate, report. The machinery of planetary defense was set into motion, and though the ending was relief, the process revealed its strengths and weaknesses. Strengths first. The International Asteroid Warning Network proved its worth. Observatories across continents shared data in near real time. Independent confirmations trimmed uncertainty quickly. Agencies communicated clearly, avoiding panic while emphasizing vigilance. Humanity, for once, acted as a species rather than nations. But the weaknesses loomed larger. Detection still comes too late. Many city-killer asteroids remain undiscovered, hidden in the glare of the sun, or simply too faint until close. Chelyabinsk in 2013 was a 20-meter rock, small, yes, but still capable of injuring over 1,000 people. Objects 10 times larger, like FA-22, remain poorly catalogued. We know of perhaps 40% of them. The rest wander uncharted. Space-based observatories, like NASA's upcoming NEO-Surveyor, are critical, but still years away. Until then, the blind spot persists. September underscored this with unnerving clarity. We are better than before, but still vulnerable. Comets, too, revealed challenges. Unlike asteroids, they can flare unpredictably, their orbits perturbed by jets of gas. Predicting their paths is harder, their warnings shorter. Swan, beautiful in Virgo, might have been an existential threat had its trajectory aimed differently. The same icy chemistry that makes comets beautiful makes them unstable, difficult to anticipate, dangerous in their own way. And then there is the interstellar wild card. Atlas may be harmless, but its speed alone would make it nearly impossible to deflect if it were on a collision course. Local defenses rely on decades of lead time. An interstellar visitor gives us months, at best. Against such objects, the only defense is luck. What September taught us was not despair, but humility. The heavens are not empty. They are crowded with rocks and ice, reminders of the solar system's violent youth. They will not stop arriving. Our choice is not whether, but when, and whether we are prepared when that time comes. DART's success in 2022 proved we can nudge an asteroid. HERA will soon refine the details. But September 2025 reminded us that practice is not optional. The next rehearsal may be the real thing, and in that test, there will be no second chance. By October, when the frenzy of September began to settle, the data seemed to insist on randomness. The asteroids were independent flybys, each with its own long-calculated orbit. The comets had been on inbound trajectories for years, their clustering explained as coincidence sharpened by better surveys. Atlas's path was hyperbolic, unbound, drawn from the interstellar dark by nothing more than galactic drift. And yet, the human mind is reluctant to accept coincidence when the stage feels so crowded. Was it chance that asteroids swept past in a wave, comets flared in clusters, Apophis hovered in memory, and an interstellar visitor arrived all in the same season? Or was there a hidden connection, a thread of causality we had not yet learned to see? Speculation bloomed. Some invoked gravitational cycles. Just as Jupiter stirs families of asteroids into resonant swarms, perhaps deeper tides galactic, even occasionally shuffle debris toward the inner solar system. Could Earth, this September, have drifted into such a stream? Others leaned toward chaos. The solar system is filled with countless fragments left from its birth. Clustering, they argued, is not a message but a statistical inevitability. If you flip a coin long enough, eventually a strange run will appear. September was a run of heads, nothing more. And then came the wilder ideas that Atlas was not just coincidence, but signal its arrival timed with a storm of local bodies to draw attention. That the galaxy might be seeded not just with debris but with intention, that the universe itself had rhythms we did not yet understand. Most scientists dismissed such leaps. Data is the antidote to imagination's excess, but imagination has its place. Many of history's greatest discoveries began as questions that seemed improbable, even absurd. Why do planets move as they do? Gave us gravity. Why does light split into colors? Gave us spectroscopy. What if these events are connected? Might someday reveal forces we do not yet know. For now, no such force is proven. September's asteroids were rocks, its comets were ice, and Atlas was a wanderer from another star. Each event had its own origin, but together they created a tapestry too rich to ignore. And perhaps that is the deeper truth. Connection lies not in physics, but in meaning. For humanity, the clustering of celestial visitors in a single month was more than coincidence. It was a reminder of our fragility, our vigilance, and our place in a galaxy alive with motion. Whether the heavens spoke with intention or not, September 2025 made us listen. And in that listening, we found connection enough. September 2025 ended with no impacts, no disasters, only questions. But the sky does not stop performing. What happens next? What stories might unfold in the years and decades ahead? One scenario is reassurance. Perhaps September was an anomaly, a statistical cluster made visible by our new instruments. In this case, the lesson is simply vigilance. Asteroids and comets have always been here, and now we are finally noticing them. Atlas will fade into the dark, the comets will disperse, and the headlines will quiet. Humanity will return to routine, wiser but unchanged. Another scenario is warning. The very fact that FA22 and RJ2 were discovered so near to Earth, so late in their approach, proves our vulnerability. The next rock of similar size may not miss. It could arrive from the sun's blind spot, explode over a city, or strike an ocean with tsunamis that redraw coastlines. In this future, September is remembered not as spectacle but as prelude, the rehearsal before the event that forces global cooperation on planetary defense. There is also the scenario of discovery. Atlas, studied with JWST, Rubin, and other observatories, might reveal chemistry unlike anything seen in our solar system. Perhaps it carries exotic organics or isotopic ratios that prove life's building blocks are common across the galaxy. In that case, September 2025 becomes remembered as the month we first compared our cosmic recipe with another star's, a scientific milestone, not of fear, but of wonder. And then, the boldest scenario, meaning. What if interstellar visitors like Atlas are not just debris, but intentional messengers? What if September's convergence is not accident, but choreography we do not yet understand? If future objects reveal patterns too precise to dismiss, then September may be seen as the first chapter of contact not with spacecraft or signals, but with the quiet arrival of artifacts adrift between the stars. The truth, of course, may be quieter, but September sharpened our imagination. It reminded us that the future of planetary defense, astronomy, and even philosophy hinges on how we respond to such moments. Do we prepare, or do we dismiss? Do we wonder, or do we grow complacent? The scenarios ahead are many. A catastrophic impact, a breakthrough in exoplanetary chemistry, a galactic pattern revealed, or simply the ongoing, humbling awareness that the universe is never still, and Earth is never separate from its motions. What comes next is uncertain. What is certain is that September 2025 has changed how we watch the sky, and once attention has been awakened, it is difficult to look away. September 2025 did not give us answers. It gave us perspective, and in that perspective, humanity glimpsed its true scale. A fragile species on a small blue world, orbiting an ordinary star, caught in the endless drift of rocks, ice, and wanderers from beyond. The asteroid wave reminded us of danger. FA22 could have erased a city, RJ2 could have shattered lives, and countless smaller bodies slip through our defenses every year. We are vulnerable, more than we like to admit. Our survival depends not on luck alone but on foresight, on building the vigilance and technology to defend ourselves against the universe's indifference. The comets reminded us of wonder. Swan, with its glowing green coma, was fragile beauty written across the sky. Comets have always stirred human imagination, and in their fragility we see our own, fleeting, luminous, temporary. Yet, they also connect us to origins. Perhaps it was comets like Swan that once delivered water and organics to Earth, seeding the potential for life. In their tails, we see our past. Atlas reminded us of scale. It was not of our solar system at all, but a fragment of another, an exile drifting for millions of years before arriving in our skies. Its chemistry spoke of alien kitchens, other recipes for worlds, other possibilities for life. In its passage, we learned that our solar system is not unique. that the galaxy is rich with stories we have only begun to read, and all of it together reminded us of responsibility. For the first time in history, we are a species capable of reading these signs, not as omens, but as data. We can measure, model, and act. We can nudge asteroids, track comets, analyze interstellar chemistry. The universe will not bend for us, but we can choose how to meet it, with fear or with preparation, with superstition or with science. Our place in the cosmos is not central, it is precarious. Yet in that precariousness lies meaning. To be small is not to be powerless. To be vulnerable is not to be doomed. It is to be challenged, to rise, to learn, to imagine, and to prepare. September 2025 was not the apocalypse. It was a reminder that the universe is vast, alive with motion, and indifferent to us. But it was also a reminder that we, uniquely, can notice. We can turn coincidence into lesson, danger into strategy, spectacle into science. And in that noticing lies our dignity, fragile creatures on a fragile world, aware of the sky that surrounds us, and awake to our place within it. 3. I Atlas was only the third confirmed interstellar object in history, but astronomers are convinced it will not be the last. In fact, it may mark the beginning of an era, an age when such wanderers become routine, no longer once-in-a-lifetime events, but steady arrivals catalogued, studied, even intercepted. The statistics demand it. If 3 have passed within a single decade, then the galaxy must be littered with them. Each star system, when young, ejects countless fragments, planetesimals that fail to form planets, flung outward by the gravity of giants. Over billions of years, these castaways accumulate, filling interstellar space with debris. By some estimates, for every star you see in the night sky, there may be thousands of Atlas-like objects drifting unseen. We are only now learning to catch them. New telescopes will change everything. The Vera Rubin Observatory, with its nightly scans of the southern sky, is expected to find dozens in the coming years. Infrared missions like NASA's NEO Surveyor will detect them even when faint. And as our technology advances, the dream grows bolder. Not just to observe interstellar visitors from afar, but to meet them up close. Already, mission concepts are on drawing boards. Small, fast probes that could be launched on short notice, intercepting interstellar objects as they pass. Some designs imagine swarms of nano-satellites. Others propose high-powered boosters waiting in orbit, ready to launch at a moment's notice. The challenge is speed. These visitors arrive fast, often tens of kilometers per second. To chase one is to attempt the most difficult pursuit in spaceflight. But the reward would be immense. A direct sample from another star system, the closest thing to interstellar exploration we may achieve for centuries. Imagine it, a probe slamming through the coma of a visitor like Atlas, scooping up dust that has traveled for billions of years, or a spacecraft landing on such a body, drilling into ices that formed under an alien sundae. The data would dwarf anything we could learn from telescopes. It would be the first hands-on encounter with material from beyond the solar system, a true alien artifact, natural, but no less profound. And with it, the questions would deepen. What if we find organics far richer than those on our comets? What if we find molecules we have never seen in nature before? What if, one day, we find something unmistakably artificial, a shard of technology, drifting through the dark, forgotten by its makers? The future of interstellar visitors is not speculation, it is certainty. They will keep coming. We will keep detecting them. And as we do, our understanding of the galaxy will shift from distant starlight to tangible contact. Not with civilizations, perhaps, but with the building blocks, the debris, the survivors of countless other worlds. Atlas is not the end of a story. It is the beginning. A beginning that promises the galaxy is not remote, but immediate, that fragments of its history brush past us, waiting to be noticed, and that the next visitor may already be inbound, its faint light creeping toward discovery. September 2025 will not be remembered for catastrophe. No cities burned, no oceans rose, no world ended. Instead, it will be remembered for what it revealed: a month when the sky reminded us that we are not insulated from the cosmos, but immersed in it. The asteroids reminded us of danger. FA22, RJ2, and their companions showed how narrow the margins of safety can be, how small the difference is between an astronomical curiosity and a human tragedy. They demanded vigilance, planning, and humility. The comets reminded us of wonder. Swan and its kin painted beauty across the night, fragile and fleeting, symbols of both creation and destruction. They carried whispers of origins of oceans, of organics, of the spark of life itself. Atlas reminded us of scale. It was not from here at all, but from somewhere else in the galaxy, a relic of another star's birth. It passed into our sight at the very moment when we had the tools to study it. Its chemistry, its trajectory, its very existence showed us that we are not isolated, but part of a galactic web alive with motion. Together, they gave us something greater than fear or awe. They gave us responsibility. For the first time in history, humanity has both the knowledge and the tools to act. We can track, we can deflect, we can analyze. We are no longer passive spectators of the heavens. We are participants. This is what it means to be citizens of the cosmos. To recognize that our planet is not an island, but a ship sailing through a crowded sea. To understand that survival depends not only on defending against danger, but also on embracing wonder, on learning from what passes us, from rocks and ice to interstellar messengers. Cosmic citizenship demands vigilance, yes, but it also demands imagination. To prepare for threats we cannot yet see, and to dream of possibilities we cannot yet prove. To see in a fragment of ice from another star, not just data, but connection, a reminder that the universe is vast, alive, and, in its own way, generous. September 2025 was not a warning of doom. It was an invitation to look up, to pay attention, to step into our role not just as inhabitants of Earth, but as citizens of a larger cosmos. The stage is set. The sky will perform again. The question is, will we be ready to listen?